Hello everybody and welcome to the intro in C. So the first thing I'm going to do is I have two terminals open here on my Mac. If you are working on a Windows machine, you can download PuTTY, which will enable you to log in into the Cori machines. You can also follow this using C-Line or any other IDE for C and C++. So I'm going to show you how to do this with the terminal first. So we'll say SSH. So SSH is a protocol that is used to remotely log in into other machines. So I'm going to go ahead and use my bottlenose username at login.cori.neu.edu. Okay, so SSH, and then this is your bottlenose username at login.cori.neu.edu. Okay, it's not your email. All right, so it's your bottlenose username. So let's go ahead and click enter. It's going to go ahead and ask you for your password. So go ahead and enter it. Okay, and now it's going to say, hey, you're logged in into loginstudents.tcs.neu.edu. So this is another machine, or this is a server that we logged into on the Cori at school, right? Okay, so let's go ahead and clear the screen here. Clears the screen in the terminal. If I do an ls, it will show me everything that I have in my home folder. I'm going to go ahead and do an mkdir. This is to create a directory, make directory, and I'll go ahead and say CS3500C intro. All right, and then I'm going to go ahead and do a cd. CD is for change directory. So I'm going to go ahead and do a cd CS3500 C intro. Okay, if I do an ls, there's nothing there. If I do pwd, it actually shows me the whole path. This is provide working directory, so this is the path where I am at. Okay, and then I'm going to go ahead and use Vim here. So Vim is a text editor that you could use in the terminal. There's other text editors that you can use, but Vim is the one that I'm going to show you. And let's go ahead and say test. Let's do example one actually, example1.c. All right, so I'm inside of Vim. So notice that if you type anything, you might not type. If it doesn't type right away, you would have to go into insert mode by pressing the I button. Okay, so for example here, I'm outside of insert mode. I have to press I to go into insert mode. That's how you start typing. There's command mode and there's insert mode. Command mode, for example, if I'm in insert mode, I would press escape and then shift colon, and I can type any commands here that I want. I believe there was what set number, and that will add that added numbers to my, sorry guys, that added numbers to the editor. Okay, so let's go ahead and here I'll say int main, and I will go ahead and return 0. Notice how this is similar to the main method in Java. In C you can have functions. Okay, you don't have to have a class to make a function. In Java you need to have a class. Functions are not existing really, they're methods, or at least static methods in Java. But in C you can have functions. Well, speaking, C doesn't have classes. Okay, it has structs. All right, so this is our most basic program. Let's go ahead and see how we can run it. So I will say escape, shift colon, W to write. Write will save the file. Okay, and I have another terminal here, so I'm just going to go ahead and SSH with the other terminal. There we go. Clear my screen. We'll do cd CS3500C intro. And in order to run my program, I have to feed the text through a compiler. So I have to say GCC, or you could use Clang. These are compilers that transform our C code into binaries. So I'm going to go ahead and use, doesn't matter which one you use, I'm going to use Clang, and then I'll say test.c. Actually, I forgot what we named our file, example1.c. So we'll say Clang example1.c. Notice if I press tab, it will autocomplete for me. Alright, and if I do an ls again, I have this green file here, executable, which is my program. So nothing happens right now. Don't worry about why I'm saying dot slash. It has to do with dot is the current directory. So I'm saying inside the current directory, run a dot out. So in order to remove it, I can just say remove a dot out. Alright, so let's clear the screen, do an ls again. And I can also do Clang, we'll say example1.c, but then I'll say -o, and I'll say my first program. And there it is. So when I say -o, this is a naming option which will name my program here, okay? And the dot slash here has to do with the search path because, for example, ls, mkdir, pwd, these are all programs that are on my search path. And currently, if I just say my first program, I'm not going to be able to run it because it's not on the search path. So I have to give it the whole path. So I'm going to say, okay, in the current directory, go ahead and run my first program. Because if I just say my first program here, you can't find it because it's not on the search path. So I have to say, inside the current directory, go ahead and run my first program. Okay, so let's go ahead and do a print hello world here in C. So I'll say hashtag include stdio .h. All right, so the hashtag include here is an import statement. So the same way we do import packages in Java, I can include files here. Okay, we'll understand what this means later on. But let's just make sure that the import statement is correct. So we'll just come here and say, I'm going to go ahead and remove my first example, and we'll just say clang example.c. All right, nothing is happening, right? So now I can, since I've included stdio, I can go ahead and print something to the screen. So I'll say printf hello world and do something like this. So notice how printf is very similar to string.format. So this is what we did in Java. All right. I believe string.format is trying to emulate what printf is doing because I believe printf is older than string.format. So let's go ahead and save our file. So D for digit, new for new line. All right. Very similar to the format in Java. So let's go ahead and do a clang example1.c. And I'll run it. It says hello world 21. Great. All right, so instead of me saying clang example1c dot every time, I can make what is called a makefile here that can compile my program for me. Because when we start getting more files, this typing all of this every time will get a little boring, time-consuming. So what I'm going to do is I'm going to go ahead and I'm going to make what is called a makefile, and in here I'm just going to say all. Don't worry too much about what exactly I'm typing here, but I'm going to say gcc example1.c. all right, and I'm going to go ahead and save this file and quit. So again, in order to exit, I press escape, shift colon, WQ, right, and quit. This is for Vim. Again, if you're following on an IDE, obviously you don't have to do these things. All right, so now if I do an ls, I have my makefile here. So there's a program on Linux machines, it's called make, that reads this makefile and then executes the commands that are in there. So if I just say make, it's going to go ahead and run this command here. If I say make all, it's going to do the same thing because I named, so if I do cat makefile, I named this command here all. I can have other commands here that do different things. Okay, so if I do an ls here, right, I have a.out. So to remove a.out, I can just say rm a.out, right? Or if I wanted to be fancy, I can say remove everything that ends in .out. So the star here is a wild character symbol that matches anything. And then so match anything that ends in a.out. Don't do that with remove though, in case you mess something up. I would advise do an ls, for example, of something like this. Okay, see what the ls command gives you back, and then change that to an rm. All right. The simple ways to do this though, I'm just going to write another command here. I'll call this clean, and we'll say rm for right now a.out. All right. So I have two commands right now. I have make all, or if I just say make, and I can say make clean, which will remove my executable. All right, so I have a make file now that makes my life a little bit easier. If I wanted to compile my program, I'll just say make, and there's my executable there. All right, so let's go ahead and run it once again. So we'll say a.out. All right, excellent. All right, I'm not going to show you reading from the keyboard yet because it involves pointers, and it's a little bit, we'll see later on. All right. But similar to Java, C is a typed language, so meaning there's type. I can say int a equals 5, char c equals c, double b equals 5.5. I have also long int. I have unsigned int. If I can type. Right, so these are all types that I believe Java doesn't have. Long means double the size of a regular int. Unsigned int means you can only have positive integers. If I wanted to make it really a big integer, I would say long unsigned int. All right, so anyway, just something to be aware of. We're not learning C here to become experts in a few lectures. Just be aware that you have these long and long unsigned int. Strings are a little bit weird in C. They are characters of arrays. So if I wanted to create an array, let's say an integer array, I would say int array, and let's say size 3. Let me go ahead and I'm going to go ahead and remove these here. So this is how I create an array of size 3. And I can go ahead and say, for example, array of 0 equals 5, and then let's just take this, comment this line, and I'll say here printf d, and I'll have array of 0 here. All right, so save. Let's go ahead and make it. All right. It says 5. Okay, this is how I declare arrays here. Notice that in Java, we would have done something along the lines of equals new, int la-di-da. New has a very special meaning in C++. In C, it doesn't have any meaning. Anyway, we'll see what new means in C++ later. It has to do with declaring references and declaring pointers. All right, so that's how we declare an array. There's no templates in C. There's no type T, so I'm not going to say something like list T, right? Or list int or array list integer. It doesn't exist in C. Okay, so there's no classes in C. You have to remember that. C++ is the addition on C where classes came into play. All right, so if I wanted to create a string, I would have to do something along the lines of, char 5. So I want a character array, and then I'll say something along the lines of hello. But you have to be careful. Strings end with a special character, especially escape character that signifies the end of the string. So I have 1, 2, 3, 4, 5, 6 characters here. So this should be a character array of 6. All right, that's how you do strings. There's other ways to do strings. There's a way to do strings with pointers. We're going to look into that later. what did I do here? Oh, it probably doesn't like the initialization here. Oh, I didn't put a name for the variable, so we'll say here string. Okay. Let's see that again. What's going on here? Char 6 string equals hello. I don't think it likes my my initialization here. I think it doesn't support it. This version doesn't support it. Let's just go ahead and try this for the time being. And let's clear the screen. Let's make. Oh, I'm confusing my. I should read my error messages. Mixing languages in here. It comes afterwards. So there we go. Character array of 6. All right. I was mixing Java in there. All right. Let's go ahead and make that. All right, that looks fine. And I'm going to go ahead and say, oops, I didn't want to do that. And we'll say, let's see if it'll let me do this. All right, and then I can go ahead and print it. So we'll say printf. S is for strings, so we'll just say here string like that. Okay. Say make. Let's run. It says hello. Okay, so those are the basic types. Let me go ahead now and clear the screen here. And oops. Okay, let's go ahead and take a look at how we can write something similar to a class right now. So C has, as I said, structs. So I have to say struct. We'll call this student struct. Okay, and the student can have we'll say age and an ID for now. Right, and that's how I define a struct. So very similar to classes in Java, except that there is no public, there is no private, there is no methods in here. So it's a very bare bones class that can only store data. That's it. There are ways to store functions or methods in here, but it's a little bit different how it's done. All right, so let's go ahead here and I'll say here printf. I'll printf the age and an ID of a student, but I need to create a student first. So we'll say struct student s1. All right, and here I'll say s1.age equals 21, s1.id equals 1001. So now I can come here and say s1.age, s1.id. Okay, let's go ahead and run this. So let's say make, clear the screen, 21, 1001. Okay, excellent. So now I can go ahead and maybe try writing helper methods or helper functions here. So this will kind of remind you more of Racket, I think, than it might remind you of Java, because there's functions in C. So here I'll say void print student, struct student. We'll say struct student a student. And I'm just going to go ahead here and say printf, essentially what I have down below. So now I can come here. Okay, and we'll just say here print student s1. Okay, let's go ahead and make this. What did I do here? I think I misspelled student. STD, it says student. There we go. All right, and save that. We'll come here, clear the screen. Let's make again. And I said S1, this is a student here. I think my fingers are still on vacation. A student, they're not typing the right things. A student, all right. Let's try that again, perfect. All right, let's go ahead and run our code, perfect. All right, so this is the way we'll write, for example, toString. So this will be something similar to saying, toString in Java. Again, at this point, I'm not going to show you how to put this inside of the struct here because it has to deal with pointers. So we're not going to look at that yet. All right, so print student. Let's see how I can make a constructor here. So we'll say void make student, or let's do an init student. Init student. So I don't want to keep typing struct everywhere. Okay, it's getting a little bit too much to type. So what I'm going to do is, there's a special word in C, it's called typedef. It means type define. Define all this type with a different name. So I'm just going to go ahead here and say student underscore T. So this is like a notation that people use in C when they create typedefs and structs. Usually structs end with underscore T. So it tells you that whatever this is, it's a struct that you're dealing with. So now I don't have to type struct everywhere. So I'll just say student underscore T because I type defined struct student to mean student T. I've type defined this to mean student T. All right, so I can go ahead here and also do student underscore T. Okay, so init student, I'll come here and we'll say student T, a student, and I'm initializing it, so we'll say here int age, int ID, and here I'll say a student.age equals age, a student.id equals ID, and here instead of calling this, I'm just going to do init student. Now this is not going to work, and I'll get to the reason why in 1 second. Let's just make sure that it doesn't work. Oh, right, init student, we need here a age and an ID. Okay, so let's go ahead and try that again. Okay, and oh, it's not going to work. So the interesting part is, not only doesn't work, but we have a lot of garbage. We have garbage data. So that's why I like in Java to always initialize my variables, because in C, if you don't initialize your variables, you'll get garbage data. But you're saying, Vito, why doesn't this work? We called init student, right? We pass S1, and it's doing this. The reason is everything in C is passed by value, meaning everything is passed as a copy. Okay, so this A student here is not the same student as S1. It's a copy. A student is a copy of S1. All right, so we'll see how to not pass a copy or pass by reference. But the other thing I want to point out is in Java, we're kind of used to, maybe there's no need for me to do this on 2 steps here. Okay, 1 step and 2 step. I would like to combine it on 1 step. Okay, so essentially what I want to do is I want to do something like this, so it looks more familiar to us. So I'll just say here, like a factory method in a way, So we'll say equals make student. All right, and then instead of void, I will return here student T. I will not take in a student. All right, there we go. And here I will make a brand new student. So we'll say student T, a student, and I'm going to initialize it here, and I'm going to return a student. Okay, so I'll say escape, shift colon, W to right, clear the screen. We'll say make. What happened here? Did I misspell something? Invalid initializer. Maybe I didn't save my file. Let's see, student T S1 make student T. Oh, yeah, the error messages in C are not the clearest. Make student. All right, I had init student there. Okay. All right, so we'll say GCC. Sorry, make. And there we go. All right. So this works fine now. This is a little bit inefficient, but I'll explain a little bit later why. Currently, everything that you return from a method, from a function in C, it's making a copy by default. So it's going to make a student and it's going to return a copy of this student back. So it's the compiler might optimize this, but I wouldn't count on it. All right, we'll address this later. The next thing I want to do is for example, have a setter like we do in Java, right? A mutator. The reason why I'm showing you how to create mutators is not because I'm encouraging using mutating methods. I just want to show you how we pass by reference. So we'll say void. I'm going to go ahead and say maybe update ID, update age. Let's just do the age. And I'll say, all right, a student, and then we'll say int new age. And here I will go ahead and say a student dot age equals new age. All right, let's go ahead and compile. All right, and now here I will go ahead and after I'm printing, I'll say update age S1 and I'll update it to 22, and then I will print the student again. Okay, so we'll say S1 here, save our file, we'll make. All right, look at that, it didn't change. It didn't change, okay? So the reason why it didn't change is because, as I said, everything is a copy. Everything is passed by value, or it creates a copy in C. So if I pass S1, the whole struct will get copied, and this is a brand new structure here. So what I want to do is I want to tell C that I'm going to pass this by reference. Okay, so I don't want you to make a copy. I want you to pass it by using the memory address. Okay, so copy the memory address or copy the reference that I'm going to give you. Don't copy the whole structure. So essentially what I need to do is when I say update student, update age here, I don't want to pass the whole object. I want to pass the address to the object. So I want to copy the address, not the whole object. Java does this automatically for you. So Java does this step right away. Okay, and that's why it's hidden from you. But when I put the star here, it means that now a student is an address to a student. That's what it means. And if I have an address, I will have to use the arrow operator. Okay, like that. And then here, when I say update age, I have to go ahead and I have to pass. I have to get the address of S1. So the ampersand here gives me, it's an operator. Okay, it's an operator that takes an object or a struct and gives me back the address. Okay, the star here, it's not an operator. This star is part of the type. This is a student T pointer or a student T star. So this is an operator. This is part of a type. Now to make things even more confusing, I can write the arrow operator here. I can also do this. I can say star a student dot age equals new age. All right, so this approach here is equivalent to this approach here. The star here acts as an operator. It's a dereferencing operator. So it means go to this address, get the object that lives there, and then access its age. This star here acts as as an operator, this star here acts as a type. So if a star becomes before a variable, it will act as a operator. If a star comes after a type, it will act as a type, as part of the type. So this is a dereferencing operator here, and it says go get me the object at this address. That's what the star means, and then access its age. So instead of typing this, people just use this shortcut notation where is the arrow operator. Okay, so the arrow operator can only be used on pointers or on addresses. So addresses in C are also called pointers. So this will be a student pointer here. Okay. All right. Now let's see if this will actually work. So say Shift W to right, and then we'll come here and we'll say make, and let's run it. And look at this now. It's updated. Okay. Pretty good. Pretty good. We are moving along. So the next thing I want to do is I want to optimize, I want to optimize this method here. I don't want to return back a copy. I want to omit doing the copy here. Okay, and you'll see this also in C++, which builds on top of C, and you'll see how the copy gets created and all of that stuff. But for right now, you might think that the easiest thing to do is to just return a pointer, return a pointer to the student that you're making in this method. So you might say, all right, let's just do this. Let's just do that. All right, and you're on the right track, because you're making a student and we're returning the address to the student that we made. So we're not making a copy here anymore, because we're making something and then we're returning the address to that thing. And I have to modify here. I have to put a star there, because now make student returns a student T star. So I have to go ahead and the type has to be a student T star. All right. Now this will work, but we'll get a warning, and let's see what the warning will be. Right. Do a clear here, and we'll say make. Okay, boy. What happened here? Did I mistype something? I'm getting a lot of errors. Let's see here. Oh, okay. I see what it is. So it's complaining that print student here, right? The print student is of type student T, right? And I'm passing in a pointer. I'm passing in a student star. So you might say, Vito, no problem. You can just put a star here, and this will work, because the star brings back the object. So S1 is a pointer. If I put a star in front of it, star S1 is actually S1. I'm sorry, a star S1 is actually the actual object. It is the actual object in memory. Okay, that's what the star does. So so S1 is a pointer, right? If I put the star in front of it, it becomes a regular struct. All right. So you might think that this is better approach, but actually this might make a copy, because it brings back the struct, and we know here if you have student T, it will make a copy of that type. All right. So although this will work, let's go ahead and just make sure. And I have to fix it down on this line too. Okay. Come here. Let's make. All right. I got a warning. Actually, I can go ahead and fix this one too, because update age takes in a pointer right there. So S1 is a pointer, so I don't need to put the star in front of it, okay? Because S1 is already a pointer. That's a pointer. If I were to do this, now I'm dealing with an address of a pointer, or a pointer to a pointer, or an address of an address, and we're not going to use that for the time being. Okay, so let's just do that. And we'll clear and make. All right, so everything works now, except that I got a warning, right? And as programmers, sometimes we avoid warnings, but actually this is very serious warning. Okay, what it's saying is, let's actually run it, and I wonder if it will crash actually. All right, so what you will notice in C, your code might compile and work perfectly on one machine, and then you take that code and you move it to another machine, okay, and it crashes. And this in C is called undefined behavior. So C is going to give you a warning, and it say, hey, you probably shouldn't be doing this because I don't know what will happen. Why is it not an error? Well, you can make it be an error, but by default it wouldn't be an error. So with C you get a lot of freedom to do whatever you want. Okay, so you cannot you shouldn't be avoiding warnings in C. You should actually probably make your warnings be an errors. And how do you do that? You just pass an extra compiler, an extra flag to your compiler. All right. So for right now, I'll just leave it like this. So what this is, let's see what this is saying. It's saying it returns an address of a local variable. What does that even mean? Well, the keyword here is local variable. All right, what happens with local variables? So local variables only live inside of a method, right? Local variables only live between this opening brace and this closing brace here. So this is a local variable. The definition of a local variable means once I get out of this scope, once I am done with the function, it will go away. So now what I'm doing is I'm returning an address of a variable that will go away. That's what it's saying, returning address of a local variable. So when this student will get created somewhere in memory, I will return the address of that student in memory, and then when the function is over, the operating system is going to go ahead and scrap this memory. So now I'm returning a memory to something that doesn't exist, because a student doesn't exist outside of this function here. Okay, so this is the sometimes you have heard heap versus stack. Local variables are onto the stack, okay, and the stack gets popped when you exit a method. Now there might be a lot of gibberish words for you, but if you end up taking C++ or C or systems, you will learn more about what the stack versus the heap are. Okay, so you will realize that Java is pretty sheltered language, meaning I don't know if shelter is the right word, but it gives you a lot of structure and gives you I would say it's less error prone or less buggy in a certain way. Okay, so essentially what I need to do here is I need to say don't make this local, make it a global variable, make it so it lives forever. Okay, so in order to do that, I have to say go ahead and create some memory on the heap. So don't put it on the stack, put it on the heap. And to do that on the heap, I need to invoke this special method called malloc. It stands for memory allocation. So allocate me some memory on the heap, and it's going to say how much memory do you need. And well, I need memory for this struct here, and the struct has two integer variables. Ints are 4 bytes, so I will need a total of 8 bytes. Now you say, Vito, this is not optimal. Do I have to count how many variables I have to figure out how many bytes of memory I need? And the answer is no. But this is how malloc works though. So in order to do that, C provides us a special function called sizeOf. And if I give it a type, we'll say student or student-t. If I give it a type, it will give me the size of that type. All right. So malloc will return me a generic address on the heap, so it won't go away. And it's an address though. Malloc returns an address. So the type here should be student-t star. Okay. And lastly, I have to cast it. I have to say cast the address, cast this void address or this generic address to a student-t address. Okay. Also in C, we don't like casting. We try to avoid it as much as possible, but you will notice that it's unavoidable. Okay, there's no generics in C. Well, there's no inheritance in C. There's no inheritance. There's no implements. There's no extends. There's no dynamic dispatch. Okay, all those things are coming into C++. Okay, all right. So we'll do that. So now a student is a pointer. So I have to go back and you know, use it as a pointer. So I have to use the arrow. All right, and then I'm going to just return a student because I don't want the address of an address. Okay, so if I do that, let's go ahead and save. We'll come here. We'll say GCC. Sorry, make. All right, so what this error is saying is implicit declaration of built-in function malloc. It's a tricky error message. It's saying I don't know what malloc is, more or less. Okay, I'm not going to go into the detail of what implicit and built-in, all that. The way to fix this is we're going to include stdlib.h. This is the standard library, and I believe it has malloc in it. Let's go ahead and give it another shot. We'll say clear and make. Excellent. And then I can go ahead now and run my program. There we go. Excellent. Everything works. Everything is perfect. We're done. Well, we're not. We've made a really big bug. And this bug is, it's called a memory leak. So every piece of program, when we run in the operating system, gets a certain amount of memory to, you know, that has it on this disposal. And that memory is the heap. So, well, heap and the stack, it gets a frame of memory. In that frame of memory, it has the stack, it has the heap, it has the code, it has the local variable, it has static variables, it has global. So pretty much a space, a real estate for your program. When you go ahead and you put something on the heap in that frame, you have to go ahead and delete it yourself, because we said don't make it local, make it live, make it last forever. That's what it means. It will stay there in forever until you get rid of it. So if you malloc in and you're never removing what you malloced, you will run out of memory and your program will crash. All right. Now, how can I check this? How do I know that I leaked memory? Obviously, I can't just, if I have hundreds of lines of code, I can, you know, track it down by just looking at it. All right. So there's another program called Valgrind that will tell you. So here I ran my executable through Valgrind, and it says, hey, you definitely lost 8 bytes of memory. How did it know? Well, how did it know it's 8 bytes? Well, we malloced 8 bytes, and we didn't get rid of them. So lastly, when I'm done using it, right? When I am done using my code, I have to come here and say free the memory, free S1. All right, and let's do clear. We'll make. All right, let's go ahead and Valgrind program again. Hey, look at that. All heap blocks were freed. No leaks are possible. That's what we want to do. However, you have to be careful, because if you try to double free, sometimes it might work, sometimes your program might crash. So if I do that again, well, let's run the program. Oh, look what happened. Jesus. I mean, what the heck is going on? Well, it tells me that there is a double free or corruption. Right? And you know, this is good, because when I run my program, I can fix it. It's not going to be random. Okay, but sometimes, you know, things could get random. And I'll show you an example in a little bit. But this right now, it says, hey, you have a double free, and tries to help you out, but I don't know how much of a help this is really. uh, you know, I get some memory addresses and other things. All right, let me try running it again, see if I get the same. Okay, try again. All right. So as you will notice, the addresses change. Notice how, you know, the addresses are different, because when I run the program, I get different memory space, different memory address. So again, you know, if when you take systems, all of this will be explained to you. You'll understand how these things, to some extent, how these things work. Okay. So let's go ahead and get rid of the double free here. All right, but what happens if I try to say S1 ID equals 2034, for example? What happens if I try to access memory that has been freed? All right, let's see what happens. So we'll say here, clear make. Look at that. There was no issue at all. But what I want you to do is, if you have a Windows machine, or if you have a Windows compiler, try to run this code on a Windows compiler, or try to run it on a Linux machine. This might crash sometimes. Accessing memory that has been freed is undefined behavior, because the memory could be freed right away and then you're trying to access it, or it could be freed at some later point in time. That's why it's undefined behavior, okay? So I put a print student here statement to try to trigger to see if I can crash it. Let's go ahead and run it. All right, it says 0 for the age, and then the ID is 34. So it didn't crash, but I bet you know, if let me try running it for a little bit. All right. This is undefined behavior. It could crash sometime in the future. That's why C is unpredictable, and some of the bugs are hard to catch. Obviously, you know, there's workarounds and there's ways we do this, but yeah, I mean, it's tricky. You have to be careful. You have to be careful how you code and what you write. All right, so in C++, you know, there's what Java does. There's smart pointers. So it actually, you don't have to free it. You don't have to malloc it. You don't have to free it. So C++ builds on this idea where they're called smart pointers. It's kind of similar to Java variables or Java references. Okay, let me go ahead and get rid of this. So you might kind of guess how you can handle this too. I mean, like the first idea that comes to mind is, remember everything that I've malloced, save it somewhere, and then when you exit, make sure you free all of those variables, right? That's a very simple type of garbage collection. Okay, but this is just an intro class, so just be careful not to, you know, not to access your variables after you free them. And let's just go ahead and quickly fix my print student here, because I shouldn't be dereferencing the pointer. Okay, and we'll change this here to a pointer. There we go. And I will update my A student here. All right, let's go ahead and save our file. Try that again. All right, and we'll clear our screen. All right. All right, folks, so we went over how to create classes, or the equivalent to classes in C. They're not classes, they're structs. There's no public or private, everything is public. There's no methods in here. Passing by value versus passing by reference. So this is the you know, student T pointer, or an address of a student, or a reference to a student. Essentially, Java hides this from you, or it's similar how Java works. We talked about how to pass a an address or a reference. If we use the ampersand, which I don't have in the code anymore here, if this wasn't a pointer, I would put an ampersand here. Okay. And the most important thing, we talked about the heap versus the stack. We talked about malloc and free. So this is one of the most important things that you have to understand in C. It's the difference between malloc and free, and what does it mean to malloc and what does it mean to free in terms of memory. Okay, I hope this quick lesson made sense. I know there's a lot of information in here. I just want to give you an idea of what to expect, or just an idea of what it looks like to kind of code in C. In the next lesson, we're going to take a look at how to write generics in C. So there are no generics in C, but the preprocessor will help me with that. Okay, and we'll see what the preprocessor is, and we might take a look at object files and how compilation works, and we might look into how to write a data structure in C. Okay, let me know if you have any questions. Thanks for sticking around and watching this over break, and I'll see you guys on Tuesday. Take care.